What's up, AP Calculus students? Mr. Ford here with another homework tutorial. This is section 4.2.1, our next kind of adventure here. We're going to be doing problems 443 all the way through problems 451. And we're going to be skipping a couple along the way. We're going to skip problems 446 and 450. So let's go ahead and jump into it. Review the results from the freeway fatalities problem in Chapter 1. Write a complete statement describing the relationship between the distance of the truck from home and its velocity. So let's start with that question right there. We've said this many times before. The relationship between the distance of the truck from home and its velocity is that the slope of the distance graph equals the velocity of the car. How can we determine the distance traveled from the velocity versus time graph? That's the other connection. This is the area under the velocity graph equals the distance traveled at any time. The last question is, how can we determine velocity from the distance versus time graph? Well, we actually already kind of talked about that in the previous answer. It's the slope of the distance graph. This is a big connection. The reason why we're still talking about it is because we started looking at integration, and now we've looked at derivatives, and we're going to start putting them together as we go forward because they're opposites of each other. There's a big connection between the slope of the distance graph and the area under the velocity graph that we'll keep hammering as we go forward. So, all right, we'll move on. 444 is going to ask us for the general antiderivative, capital F of x for each function. So, for question A, we need the function whose derivative is just a regular old cosine, and that would be the sine of x. Just don't forget to put plus c on there too. For question B, it might be a good idea to write this as just a regular polynomial. This is negative 2 times x to the negative second power. So when it comes to doing the antiderivative, what we need to do is we need to go up 1 degree because the derivative will go down a degree. So we'll start with x to the negative first power. And then we got to think that if we took the derivative of this, that negative 1 would come down and multiply, and we need it to be negative 2 in front. So let's put a positive 2 in front of that, and I think that's going to be our answer because that would be, negative 2 times x to the negative second power. Of course, don't forget plus c. If you wanted to write it as 2 over x plus c, that would be also acceptable. For question C, kind of the same game. The capital F of x in this problem, the first thing you want to do is take your x and raise it up 1 degree. 1/3 plus 1 is going to be 4/3. Just a little fraction work there. And then what we got to do is think about what number is going to go in front here. We need this number times 4/3 to equal negative 9. That's kind of the question that you want to answer, whatever is going to go in front there. The best way to do that is to do that backwards, multiply by 3 over 4. And it looks like negative 27 over 4, which seems like a weird... is that right? Negative 27 over 4. Well, if I did... I think that's correct. Negative 27 over 4 is what we're kind of looking for there. I'm just going to spot check that really quick on Calculator Cam. If I were to do in fraction negative 27 over 4 and multiply it by another fraction 4/3, would I get negative 9? Weird. Now, that's not a very nice problem, but that is the correct answer, so there you go. Pretty groovy. For question 445, we're going to use the Riemann sum with 20 rectangles to approximate the following integrals, and then use the numerical integration feature, the graphing calculator, to check your answers. I'm not sure if we're going to do both of these. We'll see how long one of them takes. But let's start with question A. If we're going to write a sigma for this, really we're going to use 20 rectangles. So going from I equals 0 to 19, let's think about the size of our rectangles. The first thing you got to remember is that in this problem, the way it works is that B, what we used to call B, is the right bound, 4, and A is the left bound, which is 0. So in this case, our delta x is going to be 4 minus 0 over 20, or 4 over 20, or 1/5, if you want to think about it that way. So really going back into the roots of where this came from. That is the width of each rectangle. Each one of these rectangles is going to be f. Let me just get rid of that first parentheses. It's going to be f of the left bound, 0, plus delta x times I, just like that. Now, the f of x in this problem is going to be, wow, is that supposed to be 3 over 2? Hang on, I'm going to switch to a different window really quick and confirm. That did not copy super well. So on that problem, that is meant to be, yes, 4x to the 3 over 2 power. I just got to confirm that really quick. I'm going to make that a little better on here. It did not copy over on this scan document like that. Now, as far as how to plug that into the calculator, I think it might be easiest if we just go ahead and use our regular old sigma process. I've been running the problems trying to make this simpler, so I'm not going to try to make it simpler. The function is 2 minus 4 times x, all raised to the 3 over 2 power. And, of course, we want plugged into that fraction, we want to plug in 0 plus 1/5 I, or in this case, I'm just going to do a fraction and call it 1/5 x. And then the way I do this, I go up now to my x in this problem, and I'm going to push alpha F4 and change that to y2. So what this will do is the calculator will run the y2 formula first and do 1/5 times whatever the x is, and then it's going to plug that into this function, and that'll give us what we're looking for our sigma. Now, back out here on the main screen, I'm going to push second F2. I'm going to open up a summation. I'm going to do x equals 0 to 19. And in this box, I'm going to do 1/5 times, and then all I got to do here is select y1, because the calculator will automatically incorporate y1 and y2 together, because we kind of made it a little mini composite function. And so the answer that we're going to kind of approximate here is going to be negative 40.038. That's good enough, like that. Pretty simple. Now, I'm just going to kind of leave that there as the answer. You can't quite see it under calculator cam right now. Now, the next thing we're going to do is actually evaluate the integral. We can do that on the calculator really easily, too. It's going to be alpha F2. You see your Fn int is right there. And we're going to go from 0 to 4. And we're doing 2 minus 4x all raised to the 2/3 power. And here's where I'm going to pray real hard, dx. I'm going to hope that I get something reasonably close to what I got for the approximation, which means I'm doing it right. It's going to think for a minute. Nope. Yikes. What am I doing wrong with these sigmas, man? That was the function, right? 2 minus 4 to the 2/3. Oh, 3 over 2. Okay, that might change things a little bit. That makes me feel a little more confident in my abilities. 3 over 2, like that. We'll see if this gives us something reasonably close to negative 40. There we go. I feel a little better about that. The integral is the exact correct answer, by the way. That's the one you want. Actually, I can push math fraction and get an actual... Oh, maybe not. Negative 43.1999. What's happening there is the integral actually does like infinite rectangles, which gives you the exact correct answer, not this approximation with 20 rectangles. Let's try B also. I don't think it'll take that much more time since we kind of have it already here. We're going to use kind of the same process for B. In this case, our B is equal to 8 and our A is equal to 1. We still want to use 20 rectangles, so our delta X will be 7 over 20. That's not a nice one, but we're just going to fudge it on the calculator anyway. Our sigma should look something like this if we're doing this problem correctly. We're going to go from I equals 0 to 19 of 7 over 20 times f of, the left endpoint is 1 plus 7 over 20 times x, just like that. I'm going to let the calculator handle most of the work there, and I'm going to do that by going into the y equals menu. Got to change a few things around here this time. First of all, in our y2, we're going to push 1 plus 7 over 20x. That's going to approximate the f of x part we got there. The actual function is the square root of 4x plus 3. And instead of x, I'm going to push alpha f4 and put in y2 there. Just like that. So it'll take 4 times whatever this is plus 3 and run it through the calculation. If this is done correctly, we should be able to go out to the main screen. Actually, we should be able to go all the way back up here and grab this exact same calculation and just change that 1/5 to 7 over 20. Just a little life hack for you on your calculator. This will probably take a couple minutes to spit out an answer. Oh, looks like it's about 30.847. And let's compare that to what the actual integral is worth if we're looking at the actual problem. The integral from 1 to 8, of the square root of 4x plus 3 dx. And it's 31.42. So I think there's probably a lesson here about just like when you compare these answers. Let me get this out of the way so you can see. When you compare these answers, how close are they? The integral is the actual correct answer. That's the thing. That's why we don't really use sigma for anything other than just kind of understanding what an integral is doing when you run it. All right, let's move on. 447 is going to ask us to use the power rule to write an equation for f prime by first expanding it and then write the equation of the line tangent to f at x equals -3. We're going to keep seeing problems like this on every homework assignment, so let's get used to it. This is 447 off to the side. The first thing I want to do is rewrite f of x by expanding it all the way out. It'll be x to the third minus 4x squared plus x minus 4. That's our original function. Next, we're going to need the derivative, f prime of x, which would be 3x squared minus 8x plus 1. And we want the tangent line at x equals 3. Tangent at x equals 3, which means we're also going to need to know what f of 3 is and what f prime of 3 is, and we can let the calculator do most of the work there. 3 to the third power minus 4 times 3 squared plus 3 minus 4 gives us -10. And f prime of 3, 3 times 3 squared minus 8 times 3 plus 1 gives us 4. So if you want to think about this, we've done a number of problems like this, but what's going to happen is we're going to do y minus f of 3 equals the slope, which is the 4, the f prime of 3, times x minus 3, and that would be the equation. I actually wouldn't go any further than that. I mean, maybe you can put that as y plus 10 equals 4x minus 12. We've come this far, I might as well. Y equals 4x minus 22. Hey, whatever you want to do. It doesn't really matter at this point. There you go. Keep practicing that process. I know it seems kind of bulky right now, but it becomes very fluid once you get a few reps under your belt. 448 is going to ask us to, this is actually a preview problem. We're actually going to disprove this thing. This is not correct. This is a no. Already, I can tell you that. Test this idea. We're going to test that idea by using this function here. H of x is equal to, they give us two separate problems. So let's just play with this for a moment off to the side. This is 448. So we have h of x, which is equal to x squared plus 1 times x minus 4. Let's call f of x the first part of it, x squared plus 1. And let's call g of x the second part of it, which is x minus 4. F prime of x would be 2x, and g prime of x would just be 1. And so if it were true that h prime of x is equal to f prime times g prime, if that were true, we should be getting 2x times 1, or just 2x. That's kind of the hypothesis zone over here. Now let's actually calculate h prime by actually doing it properly and moving it over here and expanding it out. The original h of x would be x to the third minus 4x squared plus x minus 4. Oh, it's the same problem from before. Cool. That's probably on purpose. Textbook writers. And that means that h prime of x is the same derivative from before too. 3x squared minus 8x plus 1, which you'll notice is nothing like what we got down here. This is previewing an idea called the product rule, which we won't be looking at for some time. But basically what you need to understand right now is that if you can express some original function as a multiplication like this, then you cannot do this. There's a whole separate rule you got to do to handle functions that are products. So that would not be the case. 449 is going to ask us for some composite functions. It's going to ask us to actually, split apart some things. So let's think about this. Define functions f and g so that h of x is a composite f of g of x. So I think the let's see, the best way to think about this, let's call the inside function, g of x, let's call that x squared. I think that's nice because then that can just be our inside part. And then that means that our outside part, f of x, is going to be the square root of the sine of x plus 1. And that way you can kind of see if I were to plug in x squared right there, I would get sine of x squared plus 1. There's probably another way to do that, but I think that's probably the easiest way. For question B, the inside part that I kind of see is this 3x to the third minus 12 right there. So let's make that g of x. G of x will be 3x to the third minus 12. And then we'll say that f of x, the outside part, that will be that thing squared plus 2, which is kind of what I'm seeing here. This thing squared plus 2. That works. Composite functions, splitting them apart. I don't like question 50 at all, so let's move on. 51. What's the equation of the vertical line that will divide the integral from 0 to 6, 5 dx in half? Is this the same line that will divide 0 to 6 of f of x dx in half? Okay, so let's think about this for a minute. We're talking about the integral from 0 to 6, so let's put 6 over here. Maybe you can split it up. That would be 3, 1, 2, 4, 5. Doesn't matter that much. 1, 2, 3, 4, 5. Here's your graph. It's just the graph of the straight line 5. So this integral from 0 to 6 of 5 dx is just going to be the area of this rectangle right there. As far as the vertical line that splits it in half, that would just be that line right there, x equals 3. So as far as the first part of the answer goes, we've pretty much solved it. I'm going to write it again a little more clearly, x equals 3 as the vertical line. Is that the same as the vertical line that cuts 0 to 6 of 5x dx in half? And that's going to be a hard no. That's going to be a much more difficult question to answer. I'll show you. If you were to plug in 6 to 5x, you would get 30. So you would have a triangle kind of like this, because 5x would be a straight line with a slope of 5, like that. And so the integral this time, this green integral over here, is talking about this area there. And the question there is, how do you cut that area in half with a vertical line so that the two spaces are the same? Woof. That is a much more difficult question to answer. It's going to be somewhere in here, I think. But you basically need section A to equal the area of section B, and that's a little bit more of a difficult thing to answer. We certainly will answer that question later on, but right now we don't really have the tools for it. It's easy when it's a rectangle, but it's really difficult when it's a right triangle, so not quite the same thing. Hope you enjoyed this homework tutorial. It's a pretty short one. Came out well under 20 minutes, which is great. Don't forget, you are awesome. Keep it up. Keep working at it. You're gonna get it. You're great. You're getting better every day. I'll see you in the next video.